All right, so yeah, my name is Lynn Kaluzienski, that's how you say that, and I'm a student at the University of Maine in the field of glaciology. And today I want to talk about the larger picture of accelerating the pace of climate science, just my personal perspective. And so everyone in this room is well aware that we are in a time, we're experiencing changes in the cryosphere. Over the last 2 centuries, the global mean temperature has risen by 0.6 degrees Celsius, and it's projected to increase by 6 degrees by 2100. Over 90% of the alpine glaciers in the world are retreating. Glacier National Park will be without glaciers by 2030, it's predicted. And in addition, the major ice sheets in the world are experiencing drastic changes. So these statistics and headlines are alarming, and these changes are only accelerating. So I believe that we have an opportunity to not look at this through a cloud of cynicism, but search for a silver lining. We can see it as a challenge to accelerate the pace of climate science. On October 4th, 1957, the Soviet Union launched the first satellite into space, and this marked the beginning of the space race. Over the next 12 years, the race challenged scientists and engineers to constantly innovate and continually advance their technological abilities until we finally were able to put the first man on the moon. So perhaps we can view our current predicament as a new era, the climate race, where we will be constantly challenged to innovatively observe, understand, and adapt to our changing world. There are many ways to accelerate our field of science, from increasing the amount of scientific data by launching satellites, with greater data storing capabilities and transmissions for higher resolution imagery, or accelerating data processing times with increased computational efficiency of supercomputing. So today I'm going to focus on how to improve our scientific measurements by incorporating technological advancements to obtain higher resolution field observations. My current project studies the Ross Ice Shelf, and we know that its current stability is largely governed by a pinning point along its western lateral margin. This includes Mina Bluff and McMurdo Shear Zone. Previous radar observations suggest that the shear zone is experiencing chaotic crevassing and possibly unstable ice flow. So in order to investigate further, we need a high-resolution data set, a robust data set of GPR observations to compare crevasse size and orientations with surface velocities. But of course, this area is heavily crevassed, and all the crevasses are beneath snow bridges. So how exactly should we attain in situ measurements when crevasses as big as this room could be lurking beneath the surface? Meet Yeti, a lightweight robot, four-wheel drive, battery-powered rover, specifically designed to tow ground-penetrating radar and detect crevasses. So this robot can either be operated by radio control or can be pre-programmed by GPS waypoints. And this makes obtaining high-resolution GPR observations in dangerous areas effectively easy. And so the 200 megahertz frequency resolution data set we've already obtained has literally added another layer of complexity to our work. We were able to pick up radar reflections off a basal marine ice layer, which also shows heavy crevassing. And Yeti is only one example of how it's possible to incorporate robotic advancements into our field of science. NASA has funded projects to fund test rovers for sub-ice shelf exploration so that we might see underneath Europa's oceans. And so finally, I just want to switch gears and point out one other way of accelerating the pace of science, and that's inspiring students. That's getting them interested at a younger age and inspiring them to become a scientist. And honestly, I think a lot of work just needs to be done showing students what it really means to be a scientist, because science is cool, and how many other jobs in this world involve helicopter travel in some of the remote places on the globe. So this year my team will be bringing David, middle school science teacher, with us to Antarctica through the Polar Trip program. And David will help document the trip and incorporate our research into his physics and earth science teaching curriculum. So with that, I'd just like to say that I believe it's an exciting time to be in this field, and I'm glad to be a part of it. I'd like to thank my collaborators, and as well as the Dartmouth team of engineering that makes my research possible. Thank you.